So today I want to talk to you about socially responsible artificial intelligence. Now, artificial intelligence is everywhere. It's in your pocket or in your hand if you're holding your iPhone. We talk to smart home devices that turn on our lights and play music. We've got self-driving cars. We're seeing AI applications show up everywhere. So what is artificial intelligence? Artificial intelligence is computers that learn and reason from past examples. And those past examples are data coming at. So those data examples are how AI systems learn. Self-driving cars have to drive on a lot of road systems to figure things out and learn how the system works. And there's been fantastic advances in AI technology in the tech sector in the past decade. Really amazing stuff. But we have new directions that we need to go in to push towards socially responsible AI systems. Particularly today, I want to talk about socially responsible AI in two directions. Using AI systems for good to solve critical societal challenges, and also using good AI systems. By good AI systems, I mean ethically responsible AI systems. So let's talk about examples in both of those areas. First, using AI for good. So artificial intelligence can be used across many domains because now we're collecting data everywhere. We're collecting data on climate change, energy transition. We can use this to solve inequity issues, to solve other pressing societal challenges where there's enormous amounts of data coming at us, and we can use AI to solve those. One of the areas is AI for health and AI for medicine. And I want to talk through an example from my research on using AI in healthcare. This example is from Alzheimer's disease. Did you know that 1 in 3 seniors have Alzheimer's disease or dementia? It's the 6th leading cause of death in the United States, and there are currently over 12 million people living with Alzheimer's disease. There is no understanding of what causes Alzheimer's disease. We don't have any idea. There is no cure, and there's very limited treatments and therapies for Alzheimer's disease. This is a critically pressing issue. Now, scientists and clinicians have investigated lots of aspects of Alzheimer's disease by collecting enormous amounts of data and interrogating this data using AI systems. For example, genomics. They've looked at all aspects of genomic systems to understand how it's related to AI, and found that actually only 19% of the risk of AI is explained by the genome. Only 19%. So not all the answers there. They've also looked at neuropathology and neuroimaging, which Alzheimer's disease can be readily seen on PET scans and other neuroimaging technologies. Yet, neuropathology only explains 40% of the risk of Alzheimer's disease. Alzheimer's disease also shows major differences. Recently, it's been found in the gut microbiome, all the bacteria in our gut systems. They change when people have dementia. There's also changes and factors that could possibly lead to Alzheimer's from lifestyle changes, activity levels, mental health aspects, and even things like the environment and air pollution. So many potential causes of Alzheimer's disease. Further, we're collecting tons of data from electronic health record systems, and lots of data there following patients over the course of their lifetime. The question is, we've looked at each individual types of data here to understand aspects of Alzheimer's disease, but what's missing are AI tools that can take all of these different types of data sets, each of which is huge, enormous on its own, and put them together to help understand what's going on. This is an area called data integration, where we put together lots of disparate, huge types of data sets so that we can jointly analyze them and make potential discoveries that we couldn't find if we only looked at one particular data source. In my research group, we're developing the next generation of data integration tools to merge lots of different types of data sets and make discoveries about linkages between data sets and about joint patterns amongst the subjects, in this case, the Alzheimer's disease patients. we're using these technologies in personalized medicine to understand and find potential subtypes of Alzheimer's disease, where, for example, a patient based solely on their genome, perhaps their microbiome, perhaps lifestyle factors, perhaps biosignals collected from wearable devices, might be grouped into a particular way to understand their risk of Alzheimer's disease, and eventually, these groupings can also be used to deliver individualized and personalized therapies to patients. And again, we're doing this using AI techniques in the area of data integration. So this was an example of using AI to solve critical societal challenges in healthcare. But let me switch and talk about using using good AI or deploying ethical AI systems. And you might pause and say, well, how can AI systems be unethical? They're just computers making decisions, right? Like, they can't be unethical. Like, humans are the ones that are supposed to be subjective, not computers. So what do I mean? What's going on here? Let's start and ask a simple question. Is AI fair? Okay, let's use an example. So suppose you have people in human resources departments going over resumes for job openings. Suppose you have an AI system trained to do that. Which system do you think might be more fair? Many people might say, oh, well, clearly the AI system's going to be more fair because humans might have subjective biases. There might be implicit bias that creeps into their reading of those resume systems. Surely the AI system is going to be more fair than the human one. Well, oops. Maybe not. There's been lots of examples of AI systems perhaps behaving more unfairly than we would suspect. This has been very prevalent in computer vision, for example, where recently, very recently, studies have shown that facial recognition systems might be reinforcing controversial stop and frisk policies that are discriminatory based on race. This is obviously a really bad situation, potentially based on facial recognition systems. There was a recent Netflix documentary called Coded Bias talking about how facial recognition systems perhaps discriminate against darker-skinned individuals and against women. In fact, the accuracy of facial recognition system is quite poor for darker-skinned women compared to lighter-skinned men. So something might be going on there. Another example is applications for a new Apple Card. So this happened a couple of years ago. Apple released their new Apple Card, kind of this digital credit card, and a bunch of people, of course, applied for it. And there actually was a bit of an uproar on Twitter because many people started noticing that women were often denied their credit application on this credit card, and many people spoke up about this. And many people also noted that people that had joint accounts, like husbands and wives that had joint finances and applied jointly for the card, the husbands were given different credit line limits than the wives. In fact, there are several examples where the husband was given 10 times the credit line limit than the wife. And I could imagine that might upset some people. And so there was a big uproar about this, and this credit card was issued by Goldman Sachs. And actually, the New York State launched a regulatory investigation into Goldman Sachs based on potential discrimination on this particular credit card. And they also, there was a bit of an uproar because all these people started calling in and saying, why did my wife not have the right credit line? Like, why was I denied this? And the Goldman Sachs customer service representatives could not explain what was going on at all in the AI system that had just denied these people a credit card or denied them a credit line increase. So quite an uproar here. So we might pause and say, okay, these are examples of AI seemingly behaving unfairly, but what does it actually mean for an AI system to be unfair? Okay? So first of all, AI systems are legally not allowed to train on anything that is a potentially protected attribute, such as race, age, gender, sexual orientation, and so forth. Okay, so they can't use any of that information. So Goldman Sachs was not using people's gender to make assessments on credit risk. But still there's potential unfairness. And there's two ways to understand and define unfairness in AI systems. First is the disparity in positive outcomes between groups. In this credit card example, women seem to be unfairly denied credit cards compared to men, so there's a disparity there. A second definition says that similar individuals should be treated the same way. You should absolutely not treat similar individuals who are the same on every other attribute except, say, gender, for example, then men and women should be treated the same. Both of these appear to be violated in this example. So you might say, okay, we're using these AI systems to make critical decisions in our society that directly affect people's life. So what can we do? So how have these systems become unfair? What has happened here? And there's really two major ways that this happens. First, societal bias creeps into the data that we use to train AI systems. So for example, in this credit card application scenario, it could be that past data, historical data on credit card applications, often there are differences between women's income, educational status, employment history, and other things that might affect credit worthiness. And these historical differences between men and women could actually be creeping into the training data, and hence any AI system built on data that reflects some type of societal bias will also be biased. In fact, the AI systems can sometimes exacerbate that historical societal bias. Another issue is underrepresentation. We have a lot of major, huge training data sets for AI systems that are perhaps underrepresented for women and people of color in particularly. And this can also contribute to bias. So all of these AI systems are being used to actually make more decisions about your daily life than you think. They're already being used for this, but they're also being used for things like criminal justice systems, to make healthcare decisions, obviously to make financial decisions, just like I talked about, and as well as national security systems. So we've got to figure out a way to mitigate the biases in these AI systems so they can be deployed to make these critical decisions in society. How are we going to do that? So in my research, we are looking in two different directions to help us mitigate biases in AI systems and improve their fairness. The first thing we're doing is saying, hey, it's pretty hard to improve fairness if you don't understand where the bias comes from in the model. And some of these AI systems are so big and complex, we've got to figure out what's really going on in the system first and how bias creeps into the system before we can address the issue. So we're specifically building new tools that can unravel and understand where bias creeps into learned representations in big, deep learning systems and which original input attributes might be leading to bias. So for example, in the credit history example, it could be that income and education and employment history, these are all things that, while are legally allowed to be used in credit purposes, could also potentially be contributing to bias. We need to know how those features exactly contribute to bias so we can mitigate those effects. This is what we're developing methods for. The second thing that we're doing is optimizing the trade-off between fairness and accuracy. Many have shown when you try to improve the accuracy of AI systems, you might be hurting the fairness for certain groups. So for example, in this credit card example, we might improve the overall fairness, but actually the accuracy for, say, men might decrease. And that's not a win-win. We need to create these situations where we improve accuracy for all groups. And so we're developing statistical and optimization tools that help us improve this kind of fairness-accuracy trade-off and get the best accuracy possible for all groups in these AI systems. So the overall goal is to build the next generation of AI tools that can be deployed ethically across our populations for critical decisions that do not discriminate and are fair based on age, race, gender, and other attributes. Basically, AI that is fair and equitable to all. So before I conclude, I should mention there's a lot of open, fantastic new research problems in socially responsible AI, but there's also great educational and training opportunities as well. And here at Rice, we actually have data science and computing ethics courses in our data science minor and master's in data science, as well as our computer science curriculum, where students are actually learning about some of these ethical issues about the deployment of AI systems. Further, in the D2K lab at Rice, we're increasing the number of direct social impact projects that are available to students to work on. For example, we want teams of students to work directly with partners. In this example, a team worked with the Audubon Society to build an automatic bird detection system from drones flying over the Gulf Coast island regions. Now, this type of system was a computer vision system that correctly identified and counted bird populations and can be used to monitor population changes that are critical for monitoring the environmental health, the resiliency to climate change and natural disasters, and other key metrics. We're trying to increase the number of social impact projects and opportunities for students to use AI and data science to make a direct impact in the Houston community and beyond at Rice. So just to conclude, AI and socially responsible AI is a really big, new, exciting research area that has a ton of open challenges. And we also have great opportunities for training our students at Rice in this area as well. The goal is to create these AI systems that have a positive and lasting impact on human society and help solve some of our most critical scientific and societal challenges. Thank you very much.